Hey guys, in this video we're going to be talking about statistics, which are the study of collecting, organizing, and interpreting information or data. There are many different types of statistics that we can use, but specifically today we're going to talk about something called measures of center. And these are statistics that describe the center of a data set. Now, measures of center are used as a way to describe a set of numbers using just a single number. Because when we gather statistics, we typically end up with a lot of numbers, and we need a way to summarize those numbers with just a single number, and measures of center are a way to do that. Now, there are three types of measures of center. One of them is the mean, also known as the average. So to find the average or the mean of a set of numbers, we add all of the data up and divide by how many numbers we have in the data set. So it's the sum of the data divided by the number of items in the data set. Another measure of center is called the median, and this is the middle number of the data ordered from least to greatest, or the mean of the two middle numbers if there isn't one number that is exactly in the middle. And then third, we have the mode, and this is the number or numbers that occur the most often in a data set. So think about these statements, and what do they tell us about each math class? Class A had an average test score of 63%, and Class B had an average test score of 92%. Well, what do these averages or the means tell us about the class? It summarizes the class in a single number, and it gives us a pretty good idea of how each class did on the test without having to look at everybody's individual scores. So Class A having an average of 63%, that means that a typical score in this class was around a 63%. Now, what it doesn't mean is that everybody in the class got a 63%, or everybody got a 63% or less, or everybody got a 63% or more. It's just 63% is kind of the middle. It's kind of the summary of how the whole class did. And likewise with Class B, they had an average test score of 92%. That means a typical score in this class was around a 92%. So that means some may have done better, some may have done worse, but typically the scores were centered around a 92%. So let's take a look at a data set and see if we can calculate all of these measures of center. So here in this table we have the number of representatives from each state, and we want to find what a typical state has, or how many representatives a typical state has. So we're going to look at the mean, the median, and the mode. So to find the mean, or the average number of representatives per state, the first thing we're going to need to do is add all of these values together, and I have done that already. And the sum, oh hello, and the sum of these numbers is 234. And then to find the average, I need to divide that by how many numbers I have in the data set. And there are 10 numbers in this data set. So I take 234 divided by 10, which is 23.4. So our mean, or the average number of representatives per state, is 23.4. Now you might be thinking, well, how can you have 0.4 representatives or a partial representative? But usually with averages and things like that, it's okay to have decimal values. The median is the middle number, so I went ahead and put all of these numbers from the table in order from least to greatest. And so the middle number is going to be the median. And since there are 10 numbers in the data set, there's going to be 5 below and 5 above the middle. So that would be right here. There are 5 numbers to the left of the line. There are 5 numbers to the right of the line. So notice there is no number directly in the middle. So it would be the average of the two middle numbers. But since they're the same, our median is 18 representatives per state. And then the mode is just simply the most common number, the one that occurs the most frequently. And in our data set, again, I have them from least to greatest. And 18 repeats twice, and 27 repeats twice. That means this data set has two modes. They are 18 and 27. So all three of these numbers give us an idea of what a typical state has for its number of representatives. Now they're all maybe just slightly different, but they all serve a different purpose, and we can use them in different ways. Here we have a data set of lengths of snakes at a zoo, and we want to find what a typical snake, or how long a typical snake is at this zoo. So again, we're going to find the mean, the median, and the mode to kind of summarize how big these snakes are at the zoo. So again, when I find the mean, I'm going to have to find the sum of all of the lengths of the snakes in the zoo. So you have to go ahead and add all of those up, and I've done that already to save time. And the sum of their lengths is 600 centimeters, and there are 12 snakes in this data set. So the mean, or the average, is going to be 600 divided by 12, which is 50 centimeters. And the median is going to be the middle number when they're arranged in order. And I've done that already to save time. And since there are 12 numbers, there's going to be 6 to the left and 6 to the right of the center. So 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So this is the middle right here. And again, we don't have a number that is directly in the middle. So what I'm going to have to do is average those two numbers there, or find the midpoint between them. And I don't really need to average these because I know 49 is exactly halfway between 48 and 50. So our median is 49 centimeters. And then the mode, we're looking for the most frequent number, or the one that occurs the most. And we'll notice 48 occurs 3 times, which is more than any other length of snake. So our mode is 48 centimeters. So again, typical snake, somewhere between 48 and 50 centimeters at this zoo. We can also use measures of center to compare two data sets to each other. So in this table, we see the water usage of a household during the same 8 months for 2 years. And we want to compare the mean usage and the median usage. So we're going to calculate these two measures of center for each of the years. So starting with 2010, if we want to find the mean, or the average amount of water used in hundreds of gallons, we're going to have to find the sum, which again I've already done, is 243. So to find the mean, I'm going to take the sum, 243, and divide it by how many numbers there are in the data set. And there are 8 numbers in the data set. And that gives you 30.375. And these are in hundreds, 100 gallons per month. And the 2011 mean, I'm going to have to find the sum of all of those. That's 164. And take that divided by 8. And that gives me 20.5 hundred gallons per month. And then we'll look at the medians too. The median, I put all of the usage in 2010 in order from least to greatest. And since there are 8 months, there's going to be 4 to the left and 4 to the right. And so here's the middle. And again, there is no number right in the middle. So I would have to find the average of 29 and 32. So I would add them together, and that gives me 61. 61 divided by 2 is 30.5 hundred gallons per month for the median. And then for the 2011 median, there are 4 to the left and 4 to the right. And again, no number in between, so I'm going to take the average, or the mean, of 19 and 20. And I know that 19.5 is halfway between, so 19.5 hundred gallons per month. So now I can compare these two water usages for the 2 years. So looking at the means, we can see that there was more water usage per month in 2010 typically. And then when we compare the medians, there was also more water usage in 2010 typically. So we could conclude that typically there was more water usage in this household in 2010 than there was in 2011. So how do we know when to use the mean, the median, and the mode? So here are some tips of which measure of center we should use when we're looking at different data sets. You should use the mean when you have no extreme values that are much greater or much less than the rest of the data. You should use the median when you do have extreme values, because those extreme values can affect the mean. So one extreme value can really pull the mean one direction, either too high or too low, and it can kind of be misleading. So when you have extreme values, you want to use the median because it's kind of immune to extreme values. And then the mode, it says to use that when data have many repeated numbers, but honestly, the mode doesn't really get used a lot. The mean and the median are typically going to be used about 99% of the time when we're finding measures of center. So here's an example of trying to decide, well, which measure of center should I use? And it says the table shows the high temperatures for the previous week. Which measure of center best represents the data? And justify your selection and then find the measure of center. So looking at all of the data in this table, we can see that they're all pretty similar to each other and there are no real outliers or extreme values here. So it would probably be best to use the mean. So that's why they chose the mean in this example. And then you can see from the calculation here that they went ahead and calculated that and got 86 degrees. So the temperature 86 degrees Fahrenheit is the measure of center that best represents the data. So the typical temperature that week was about 86 degrees. This table shows the number of sit-ups that Pablo had done in 1 minute for the past 7 days, which measure of center best represents the data, and then we want to justify our selection and then find the measure of center. So looking at the data set, which measure of center do you think would be best to use to describe how many sit-ups Pablo did on a typical day that week? Well, looking through the data set, we can see that they're all pretty similar except for Wednesday. Something must have happened with Pablo on Wednesday. He didn't do too well. So there is an extreme value here. So using the mean, we might not get the best number to represent this data set. So I probably would not use the mean. There aren't a lot of repeated values here. So then that would leave us the median. I would choose the median because there is an extreme value. So let's go ahead and find the median. So we're going to have to put these in order from least to greatest. And that extreme value on Wednesday is the lowest value. So we've got 19, 37, 40, 45, 46, 49, and 50. And there are 1, 2, 3, 4, 5, 6, 7 numbers in the data set. So 45 is going to be the center number with 3 to the left and 3 to the right. So our median is 45 sit-ups. So we would say that on a typical day, Pablo does about 45 sit-ups. Now, if you did go ahead and find the mean and calculate that, the mean is actually going to be much less than that. The mean here is 40.8 or about 41 sit-ups. So you can see that that one value of 19 really brought that measure of center down to make it a little bit misleading as to how many sit-ups Pablo was capable of doing each day. Here we have a situation of when we should decide which measure of center to use to maybe communicate a certain message. So the average wait times for 10 different rides at an amusement park are 65, 21, 17, 52, 25, 17, 11, 22, 60, and 44 minutes. Would the amusement park advertise the mean or the median to show that the wait times for its rides are short, and then explain? Well, if we calculate both of those, you can see that the average wait time or the mean wait time is 33.4 minutes, and then the median is 23.5 minutes. So you can see there's quite a difference here between these two. And because we had an extreme value that brought our mean up and made it seem quite a bit larger. So if I had to choose between these two, the amusement park would probably want to advertise the shorter time. So they would use the median here to say that our amusement rides have a typical wait time of about 23.5 minutes as opposed to 33.4 minutes, which makes it seem like you're going to be waiting a long time. So they'll use a different measure of center to kind of get a different message across. But we have to be careful with this because statistics can be misleading, so it's important to understand how they work. Know that some people could use these measures of center to use them in somewhat of a misleading way.